Only lun 5% of students could get this question correct, but it's nice and easy, Mike. So, lun x equals 2 over lun x plus 1, x is bigger than 0. How do we solve that? Now, imagine lun wasn't there, and you had x equals 2 over x plus 1. You would know that's a quadratic once you multiply through by denominators, right? So, what you could do to make life easier is let lun x equal u. So, u are lun x, yeah? So we get u is 2 over u plus 1 multiply through by u lun x. So we have u squared is 2 plus u. Move that over, u squared minus u, move that over. So, u, 2, 1, to make minus 1, you need that. You get u is 2, u is minus 1. So you have lun x is 2, lun x is minus 1. E to the power of both sides, I'm not going to have space, but you have e to the power of 2 here, or e squared. Then here you do e to the power of minus 1, which is just e to the power of minus 1. You can write it as 1 over e. I usually just leave it like this. Nice. E% of students got this question correct. Simultaneous equations with e in that. So, same as always, you just want to eliminate either the x or the y. Here, I think eliminating x is easier. We can double this. So we get 2ex, 2ey is 16. Then we just subtract them. Get rid of this. And then you get e to the power of 2y minus 2e to the y is 0. And we just factorize out e to the y. This is a quadratic. You can just factorize because this would be e to the power of y squared. So when you factorize out e to the y, just left with itself. Minus 2 is 0. So either e to the power of y is 0. However, exponentials can never equal 0. So we're just left with e to the power of y is 2. Ln both sides. So we have y is ln 2. But then don't forget, we need to find what x is. Might as well sub into here. So you have the value of e to the y is 2, right? So you have e to the power of x plus e to the power of y, which is 2, is 8. So you have e to the power of x is 6. Ln both sides. X is ln 6. Easy. Nice. Ln gang. Only 1.24% of individuals got their job at ASDA after answering this question. So let me show you how you get your job at ASDA. So prove that 6/5 to the power of 6/5 is approximately 1.24. Now, when I see this question, whenever we see approximations, where do we really do that? It's the binomial expansion. So I'm thinking about using the binomial expansion here. So binomial expansion, 1 plus x to the power of n. So I want to rewrite this as 1 plus something. Well, that's easy. 6/5 is 1 plus a fifth, right? To the power of 6/5. So we're just going to expand that. Now, 1 plus x to the power of n, 1 plus x to the power of n is approximately 1 plus, multiply these together, nx plus n minus 1 over 2 factorial x squared. And that's going to be all right. You can go up to x cubed if you want. Now, x in this case is 1/5 and n is 6/5. So 1 plus 1/5. I actually think, no, it doesn't really. I was going to say subbing in x is 0.2 is easier, potentially, but it's not really. 6/5. So we have 1 plus n x plus n, which is 6/5, times n minus 1. The quick way to subtract 1 from any fraction is to do the numerator minus denominator, which is 1 over 2 factorial times 1/5 squared. Now the answer was 1.24, which makes me think 1 plus, this is a non-calculator question by the way. Obviously in A-levels everything's calculator, but we should be wondering why is this even a non-calculator paper? Would they expect us to evaluate something like this? Well, probably not. Here you have 6 times, or 6 over 25. Now a 25 in the denominator is 0.04, which when you times by 6 you get 0.24. So you don't even need this bit. So it's 1 plus 0.24 which gives you approximate 1.24. As the interview secured. Nice. Prove this, hence find the integral. Let's do the first bit. Nice and easy, mate. Sine 3x, prove it is this, where we have a singular x. So we're going to have to break down the sine 3x. Right is 2x plus x. Use the addition rules. So sine goes sine, cos, s, keep that the same. S for same, innit? So sine, cos, stay the same. Then sine, you just swap the angles around, cos. Next thing we do, use our double angle IDs. Sine 2x is 2 sine x cos x. Multiplied by cos, you get cos squared. So 2 sine cos squared. Now this, we're going to rewrite it exclusively in terms of sine, which is 1 minus 2 sine squared. Here also we need to change that into 1 minus sine squared. Okay, should we do all at the same time? Let's just do it. I'm just going to write s squared. So, minus 2s, guys, I'm just going to write s for sine. It's just long. 2s times 1 is just 2s, minus 2s times minus s squared will be minus 2s cubed. S minus 2s cubed. In fact, in further maths, we do this a lot. Instead of writing cos plus I sine, I write c plus is, and a lot of us do that. So here we have 3s minus 4s cubed, and obviously in the exam, just write that back as sine. Okay, let's take this and utilize it here. Part B, find the cube root integral of this cube root function. All right, so naturally we're going to change everything so that's in terms of x. We know this is from here. This we can easily do it. So we get the integral of the cube root. I'm going to write as power half. This is 2 sine cos. 2 sine cos times 3 is 6 sine cos. Here I get negative 2 of this, which is that 3s minus 4s cubed times cos to the power of a third dx. Okay. Expanding, I get 6 sine cos minus 2c times this is minus 6 sine cos. That becomes plus 8 sine cubed c. I'm going to write the c first. c. Okay, to the power of a third dx. Boom. Looks good. This cancels. And then we're just going to cube root all of this. So we're going to cube root 8, which is 2. Now I'm going to write it properly. So we have 2. Now I'm actually going to write this one first, and you'll see why in a second. So here the cube root of cubed, it just goes. So we're left with sine x. Then we get the cube root of cos. I'm going to write like this. Because we are integrating, I notice that what's inside the bracket differentiates to what's on the outside. So I'm going to reverse chain rule here by making a guess. This is a power function. I think the power on cos is going to go up by 1. Differentiate to check. So we differentiate inside, that's minus sine. Multiplied by, bring down the power, knock 1 off the power to the power of a third. So we have minus 4 thirds. Now, we need to manipulate this so we have 2 instead of minus 4 thirds. And there's a really easy way to remember. You multiply by what you have divided by what you've got. So you do 2 divided by this. 2 divided by minus 4 thirds is 2 times minus 3 quarters, which is minus 3 over 2. So there's your answer. Minus 3 over 2 cos x to the power of 4 thirds. You can write like this if you want. Easy. Nice. Solve this question, which was asked at Greg's the other week. A student let me know it was a 1-mark question, so it must be really easy. Solve 2 arc tan half equals arc cos x. So we're solving for x, obviously. Arc cos means inverse cos, so we're going to get rid of that. Do cos both sides. X is cos of 2 arc tan of 1/2, and then we can leave it like that. Just joking. Anyway, find what x actually is. So what we're going to do is, I'm going to rewrite this. I'm going to let arc tan of 1/2 equal u. Or y, doesn't really matter. So I'm going to tan both sides and say tan of u is actually 1/2. Yeah, so tan of u is 1/2. And then we have to think about what we're actually trying to find here. X is, when you make that substitution, I could do it here, is cos of 2u. Now from here we can just do an expansion. We can rewrite this in terms of whatever you want. You could do cos squared minus sine squared, 1 minus 2 sine squared, 2 cos squared minus 1. Just for this sake, I'm just going to do cos squared u minus sine squared u, because then it forces me to work out both values using this. Here it's just simple triangles. The angle is u. Tan means opposite over the adj. Opposite 1, adj 2. 1 squared plus 2 squared is 5. Root that, root 5. So cos is 2 over root 5. So x is 2 over root 5. We are squaring that, minus sine, which is 1 over root 5. And we are squaring that. So we have 4/5 minus 1/5, 3/5. Easy. Only 9.2% of students could get this question correct. Let's do it. Prove log base 2 of 3 is irrational. This is a contradiction question. So the first thing we're going to do is assume log base 2 of 3 is rational. What does it mean for a number to be rational? It means you can rewrite it as a fraction, but we need to set some conditions. In this fraction, both p and q are integers. Yeah, they're parts of the integers. And q cannot be 0. You can also say that p and q have to be co-prime. So p and q co-prime. What does co-prime mean? It means that it's a fraction in its simplest form. Co-prime essentially means that the highest common factor between these two numbers is 1. Okay, the next thing we're going to do is get rid of log base 2. What's the opposite of log base 2? It's doing 2 to the power of both sides. So 2 to the power of log base 2 cancels. We're left with 3 equals 2 to the power of p over q. The next thing is we don't like fractional powers. So we can get rid of that by raising both sides to the power of q. By doing this, you're multiplying the powers, these cancel, and we're left with 3 to the power of q equals 2 to the power of p. Now there's many ways you can conclude this. Powers of 2 are always even, powers of 3 are always odd, or you can literally just say the numbers 2 and 3 are also co-prime, so the only solution to this is q and p being 0, which doesn't make sense because q cannot be 0. So I think the best solution here is to say both 2 and 3 are co-prime, so only solution is p equals q equals 0, which contradicts our assumption. Yep. Therefore, log base 2 of 3 is irrational. Nice. Only 9.2% of pupils could answer this correctly and secure their job at B&Q. So let's do it properly, Mike. So use substitution here to evaluate this. U is sine t. We're going to change dt into du by differentiating. Sine differentiates to cos, and we're going to multiply through by dt. The next thing I'm going to do is I'm going to change the limits. Now, here we have t is pi over 2. So t is pi over 2. What do we get for u? Sine of pi over 2 is 1. When t is 0, sine of 0 is just 0. Now, there's actually nothing to cancel out here, so we're going to have to rewrite this as well. Let's do that before we make any substitutions. So we have 0 pi over 2. Now sine 2t is 2 sine t cos t. When we square that, we get 4 sine squared t cos squared t. Then we times by that. Cos t actually makes this cos cubed t dt. Now we can make our substitutions. So here, I'm actually rearranging for dt. It will be du over cos t. So we have 0, u is 0. Then pi over 2, we have 1. We have 4 sine squared t cos cubed t multiplied by, here, remember we're rearranging for dt, it will be du over cos t. You might be asking, why didn't I change this into u? You could have done it now, you could do it later, it's up to you. I tend to do it all at the same time when it comes to trig. Cos t cancels out this to make cos squared, and then we need to change that into 1 minus sine squared. So then we can convert everything into u. So it's 0, 1, 4. Now this is u squared. Cos squared is 1 minus sine squared, but sine is u now, du. Expand everything. We get what? 4u squared minus 4u to the power of 4 du. Integrating that, add 1 to the power, divide 4/3 u cubed minus add 1 to the power, so 4/5 u to the 5, 0, uno. Subbing in 1, you just get 4/3 minus 4/5, which is 20 minus 12, 8 over 15. And then minus, subbing in 0 is just 0, so we just get 8 over 15. Nice. Only 9.2% of students answered this question correctly. We've got a hemisphere, we've got water pouring in, we've got the height of the water in the bowl of h, we've got the volume centimeters cubed in terms of h is given by this formula. So, the volume is determined by the height of water in the bowl. Find dv by dh when h is 0.1. Okay, an easy differentiation here, dv by dh. Now, what a lot of students do here is they multiply in both of these, or they do product rule. You definitely don't want to do product rule, that is long. What you want to do is keep the 1 over 12 pi outside of the bracket, because it's just a multiplier, it makes no difference. Just like when you're integrating, you can keep this outside of the integral. So instead, I'm going to differentiate 3h squared. 3h squared differentiates to 6h. Then here, you have minus 4h cubed. Minus 4h cubed, you bring down the 3, it would be minus 12. H, then it was cubed, not quantity off the power, is squared. Now don't forget you had that 1 over 12 pi. I'm just going to write pi over 12 for space. Now we're just going to sub in 0.1, which is pi over 12 times, what is that? That is going to be 0.6 minus 0.12. 0.60 minus 12 is 0.48. So you got 0.48, and that divided by 12 is 0.04 pi. Now we need part B. Part B says water flows in at a rate of pi over 800 centimeters cubed per second. Find the rate of change of h in centimeter per second when h is 0.1. Okay, this is a classic Wagwan formula. Want, got, need. So, it's what you want equals what you've got times what you need. Wagwan. So, what do we want? Find the rate of change of h. Look at the units. h, time. We want dh by dt. Now, what have we got? When h is 0.1, we have this rate of change. That is dv by dh, yeah? Volume, no, sorry, dv by dt. That is the volume with respect to time. So we have dv by dt. What do we need to multiply that by to balance this all out? So we need a dh on the top. We need to cancel out the dv. Okay, so we have this is pi over 800. Do we have dv by dh? The answer is yes. Specifically at 0.1, which is what we wanted. But we want the reciprocal of that. We want to flip this. So we're doing 1 over 0.04 pi. The pi's cancel. You multiply these together, you get 1 over 32. Nice.